Good night, everyone, and I would like to thank the NES Collective and Daniel for the invite to present here. I will talk about is WebAssembly ready for Node.js and why WebAssembly and why Node.js, because one of the main things for WebAssembly is the browser, but I will get into it. So, who am I? I'm a full stack developer. I used Angular in the past. Right now I'm using React. I'm using .NET, but I use Node. I use like everything. So, and let me start presenting you what is WAS and WebAssembly. WebAssembly is like a new standard that was created by Mozilla, by Apple, Microsoft, and Google together. But it's not like a programming language. It's most like, you can look at it like a bytecode. It's a language, but it's like assembly, so you need to compile to it. It's really compact, it's portable, it's really small to download in the browser. It's safe because it runs on the same VM as the browser, and has near native performance. It's like, and don't know if any of you use an ACL from Chrome. It was like a native layer on Chrome where you can run native code. It's almost the same thing. So the WebAssembly was born in 2009 at Mozilla in an experiment to run JavaScript code at near native performance, and they call it ASMJS. What they did, it just created like a small set of instructions from JavaScript and used some mathematical expressions to run JavaScript really fast, and then created a compiler that was emscripten that just that compiled C code and C++ code to ASMJS. And then in 2011, Google made that experiment with an ACL, and in 2013, because a lot of years passed, actually the guy that cast the idea of ASMJS was Brendan Eich, the same guy that created JavaScript in 10 days, so he knows what he's doing. So in 2013, they created the first game. Actually, the game was developed by Unity, so they compiled a C++ game and run it on the browser. The first browser to support it was Firefox, because it was like a project from Mozilla, that's why. And then in 2015, they came together and looked at what ASMJS could do and tried to develop a new thing that was WebAssembly. Because the issue with ASMJS is JavaScript code everywhere. It's just text. It's a lot of big. So if you compile like a big game to JavaScript, the game becomes too big, and you need like a really speedy connection to download it. So the main applications of it is games. It is security with cryptography, where everywhere where JavaScript falls short is mostly in performance. But actually, JavaScript is very fast, but sometimes in very computational things, it becomes really slow. And if you want to use threads, even though WebAssembly right now in this current stable state doesn't support threads, you can't do it. So that's why WebAssembly is important.
So yeah. It's not defined on the standard, but someone already has implemented it, right?
No, it is defined on the standard. Okay. It's like on the in stage 2 okay. of the standard. Okay. Chrome implemented it, Firefox implemented it. I tested all the demos I could find. Some of them work, some of them didn't work. I couldn't make it work on Node.js. I actually spent most of the Sunday trying to figure it out, but I couldn't. It just simply didn't work. So, and one of the good things about WebAssembly is it's fast in execution. Is it's very small, because they also created like a binary format for it, and as soon as you start to download WebAssembly to your browser starts to compile them to binary code, native code of the machine. So, and another thing, it's safe, as I said before, because you run it on the same VM as the JavaScript. They use the same primitives, so, and JavaScript is pretty safe.
Still like locked down.
Yeah,
So
it's the same thing. So
the same sandbox,
yeah,
right?
Yeah, yeah, it's the same. It's actually the same sandbox, and the way they implemented threads in WebAssembly, they work like web workers. They are actually like web workers. They are not out right now because they had to disable the shared array buffer because of the Spectre meltdown and everything. So they need to stop it. They need to re-implement everything. That's why it isn't yet there. It's open and debuggable, so you can go to the DevTools and you can see the binary code, you can see the bytecode, and there is also support for source maps to it. So you can debug inside Chrome or Firefox, like Rust code or C code or C++ code. It's really great. And it was developed as a W3C standard, so it's like it was built for the web by the same guy that built JavaScript. So this is an example of a function like that calculates a factorial. In C, it's like that. In WebAssembly, in text, looks like that. It looks a bit like assembly, but it is not, because it's the way that the WebAssembly code is executed is in a sequential way. So everything is on stack, the memory is linear, and they made it this way because as soon as you start downloading it, like the first lines, you can start to compile it, so you don't need the full program to do it. So, and then there is the binary that's really small. It is the performance comparison between them. It's really different. So, and everything is explicitly typed. So you have types inside WebAssembly. It's the.
This is performance. This is only performance because we skip like scripting time, optimization time, and stuff like that.
But you don't need that because you do that as soon as you start downloading. So when you start to execute it, you have already an optimized.
But the browser is doing optimization.
Yes.
Oh.
So as soon you open a page with a WebAssembly, you start to download it, it starts to compile it, and then there's like a second thread to optimize the code.
I thought the optimizations were done like before they get.
No, they are done, but they will try to like the hot paths. Yeah, because it uses the same just-in-time compiler. Yeah.
Okay.
So it's safe because it uses the same policies, the same origin, just like JavaScript. So you don't need to. It's like I said before, you can use it for debugging, testing. It's one of the things is like it doesn't have a version, so they put the WebAssembly out there. It doesn't have one or two version. They start just to add features to them. So when you compile to this works because WebAssembly is like a compilation target. You don't write WebAssembly code, so yeah.
It happens ahead of time.
Yes, it happens ahead of time, so you need to compile it. And what the compiler should do some code that just tests if WebAssembly has that feature or not. And if it doesn't, it should use like a polyfill. So without a version, you don't have version problems. So yeah.
So many questions.
And Node.js already supports WebAssembly. So the current state, they created like a minimum viable product for every browser to implement. They actually implemented, I think it was in 2016 or 2017, every browser right now in production, aside from Internet Explorer, of course, supports.
Edge supports it?
Yeah, Edge supports it. So everyone come on board to support it. I don't remember if like Safari and mobile supports it or not, but I think it does. Because
Does Android, Chrome on Android supports it? Like the mobile.
Yeah, I think so. And another way for the browser to support it, almost every major browser supported ASM.js before, and there is like someone created like a polyfill where you can execute WebAssembly code inside the JavaScript engine. So it's way more slower, but yeah, it works. So the roadmap, right now what you have, it's like you have a way to load modules, we have a way to execute code, we have types, we have like the bare minimum to start. And what they will do next, they will start shipping threads. It's shipped in Chrome 70, but it's behind the flag. It's also shipped in the last version of Firefox, but I couldn't get it to work, so I don't know if it works or not. In Chrome, I could make it work. That's why they keep all that time because of the array buffer. The next thing they will do, they are working on, it's one of the most mature things. It's a garbage collector. For that will use the same as JavaScript, even though you can implement like a garbage collector inside WebAssembly, because you can compile C to that and you can write in C or garbage collector. You have a problem with life cycles between WebAssembly and JavaScript, so it becomes a mess if you use your own. But if you use the one that WebAssembly will have, you can pass objects between JavaScript and the WebAssembly, and it works fine. This is one of the main requirements for you to compile languages like Python, like OCaml or Reason or something like that, because they are dynamically typed languages that use garbage collectors. So right now you can target like a subset, but the full language you can't because there isn't a garbage collector. In the future you have dynamic linking, so you can load like a module into WebAssembly and you can link to it. You don't need to download all the code to the same module. You
like runtime dynamic
ports, exactly. Yeah.
Right?
It's more like a little bit. It's like it's like native libraries. So yeah.
Yeah, it's like dynamic linking in the actual operating
system. Exactly. You will have like scenes, so you can make you can do like really fast data processing to it. We will have like zero cost exceptions, so because that's why the way they architecture WebAssembly to be linear, to be like a stack machine, it makes it really fast. And then they will also do tail call optimizations when you do like recursive functions and some stuff like that. There is a page where they have like the future features, like it's future releases, but there are some useful links there where you can. There is like an IDE online where you can compile code. Where you can drop your C code from the first year on your university, and you can execute it on the browser. So yeah, it's really great. And now I will do a demo. It's like I will.
Will it work?
I really hope so, because okay, let me try. Okay, what I did, I just created a giant JavaScript file that runs the code, runs the Fibonacci algorithm through a giant array. I do it in JavaScript. In iterative and recursive, and with some memoization just to see the difference. I have done it with workers inside Node, because the way that Node actually uses workers with threads, but it's mostly the same implementation as the browser. And then I used Neon Rust, that is like a framework for you to create native modules on Node.js, and that's why my talk, because there are some issues, and most of you have got to them if you use Node. When you try to use libraries like Sass and some libraries that use native features, NPM takes a lot of time. It's not because it could be that it was downloading packages from the web, but it wasn't. It was because it was compiling code for the machine. And SAS does that, and they, whenever they do like a release, they need to have like 20 different dependencies, each one for a different platform. And they do that because they use some native code, they use Ruby code, so it's a kind of a mess. They compile it to a native Node module. And one of the things that most of the people think will solve this issue is WebAssembly, because you can compile from whatever language, even JavaScript you can compile to WebAssembly. So you don't need to ship the compiled binary for that platform, because WebAssembly runs in any platform. It's like, as I said before, it's like a bytecode. And one of the things they are doing into WebAssembly, they will expose all the web APIs from the browser to WebAssembly. So you can execute WebGL inside WebAssembly. You can do DOM manipulations inside WebAssembly. There's actually a Rust web framework where in Rust, it just compiles to WebAssembly, it just manipulates the DOM. But right now, what it does, it has like, it uses proxy JavaScript for that, so it's a little bit slow, but in the future, it will be really fast. And
it's still light years away from vanilla JavaScript, right?
No, not really, because you need to pass through JavaScript, and JavaScript is really fast right now.
Gotcha.
It's one of the fastest languages if you are doing small things. Actually, there are, I think was NPM. They have like a low processor. It was written in Node. It was a little bit slow, but it's just processed like gigabytes of data. So,
fast, yeah.
But it was still very fast. And then they tried to write it on Rust, because it will be way faster. No, it wasn't, because there were some problems with the buffers and anything. So they did it, but they stuck to the JS because it was way faster. And what I did here, it was like a benchmark to native JS with workers. I use Neon. Neon is a little framework. It's really easy for you to create like node modules with Rust. You just create, I will show you the code for this. So I will make it run right now because it's a little.
Can you zoom in a little bit?
Yeah. So this is like really simple Fibonacci functions. So for the workers in Node.js, you just really use the post message and the on message. I had some issues because this post message, when you send really big data, and that's what I'm doing in this benchmark, because when you are trying to raise a single threaded algorithm to a multi-thread, you need to really big data, because it doesn't make sense, because there are too much overhead between switching context. And it worked really well. If you need to pass big things between workers, even on the browser, just use array buffers or shared array buffers, because there you have like a property. Whenever you do like a post message with a message for the worker, you can have like a transferable list of objects that only works for shared arrays and shared array buffers, and the array buffers that just moves the memory to the worker. So it's really fast. And sometimes when you have like 500 megabytes of memory to pass, it's really fast, because other way it will try to serialize it and then clone it. It's really slow. So I also did like a Rust sample where I have like just a main.
So cool.
I tried to benchmark it. There is too much overhead because the benchmark framework I use it's inside Node. So it doesn't. They execute the sync, but it's a little bit slow. I don't know why. Then I have this Neon. Neon is really great because we have like a native part of the lib where you have like Rust. You can have all your functions here, like they receive like a function context that comes from the machine, and then you just return JS result with a value.
Oh, you're a fan of Rust. I can see that.
Yeah, it's like it's one of the best things that's happened because it's like really simple, really fast, and every time you try to compile it, it just works. And it was always inspiring the ML languages, so you were really a great type system. So, and then in the end, you just register all of your functions, and they will become available on your module, and you can just call it. So it's really simple. I also used Rust because Rust was also a language created by Mozilla, and right now it's the language with the best support in par with C++ and C to support WebAssembly, where you have the most tooling, because WebAssembly also was born on Mozilla, so there are the same guys working on everything. So and they really promote inside Mozilla to use Rust to compile to WebAssembly. Then I have the WASM sample. This is garbage. You have also the same, it's mostly the same code. I have like a thing here because you need to use like the latest version of Rust compiler with some features that they aren't quite stable. And for the functions you want to be exported, you just add an annotation, was bind gen. It generates automatically the bindings. And as you can see here, on these bindings, I just use the native language type. I don't need to use like a JS number like I did on Neon, because Neon it's like a framework to communicate and to be as fast as possible. And with WebAssembly, you just use the types from, you just use your plain old language. And one of the things they say with WebAssembly, it's not here to replace JavaScript, because you will still use it. JavaScript is really great. We have a lot of frameworks written in it. But with WebAssembly, you can get like millions and billions of lines of code on C written in the past, right on the browser, so you can use your old code base. So.
Yeah, if I have a C++ or a C program from 10 years ago, I can compile it to WebAssembly. And
yeah, you can run it on the browser, so yeah.
Okay.
It's like the best thing.
Really cool.
We already have Windows 95 and Windows XP,
Yeah.
right?
Yeah.
Let's go try
Yeah,
Windows
there was,
10.
Like,
there
yeah.
was one guy that compiled the whole Windows 95 to WebAssembly, and it's run on the browser, just
That's
like the
what I'm
original.
saying. We already have that. We already have XP as well. Windows
Yeah.
XP running
Really?
on the browser, I
Oh,
think.
that's huge.
So now we need to just
Windows
go
10.
for Rocket,
So,
Windows 10. Yeah.
the
So the browser.
as you
Yes.
can,
I'm waiting for a real tournament.
let me try to zoom in here. So
Yeah.
okay. There was some of these warnings because when I'm using, because this is a benchmark, it tries to run like several times the same code. And when you use web workers, you need to bind to an event. That's why Node gives you that kind of information. So as you can see on the end, the fast is using Neon. The Neon Rest, because it's a native module, and as you could see when I showed you with Neon to create native modules, you need to specify like JS types. That's why it's really fast, because the serialization is really fast, and the code in the API of Node, in the API layer on the API interface, it's really fast. That's why it's Neon. It's really fast, but
How much faster? Is it that much? It's crazy. So it's like 10 times more than that much?
yeah,
Than WASM?
Yeah.
And like 20,000 times? No.
Yeah.
20,000 times? No, 219, yeah, 0.4.
The code from the WASM and this Rust, just don't look at it because it's running on the CLI. It's really fast. It should be the same speed or even faster than Neon, the Rust one, because all of these three use the exact same code.
Yeah, both of them are running Rust compiled for the
Yeah.
native platform,
Yeah.
right?
And the last one, if
It's actually
yeah.
WebAssembly.
the last lines shouldn't have worked. I need to figure why, because what I used for Rust, and that's why I love Rust, is yeah. It's when you need to write like parallel code. We have a library called Ryan, where you can have like a vector. You just convert it to a parallel iterator, and just use map like just a normal iterator. And this library looks at the number of cores you have in your machine and just parallelize it for the number of cores, just create the threads. You don't need to do anything.
Oh, that's cool.
And in the end, it just concatenates everything on the same thing. So when this function returns, it returns the full result from all the threads. So it's you are writing parallel code, just like you are writing serial code. Yeah. As you can see, I have in here on the top. Let me go a little bit. Oh, that's why it's Magnetus. No, it's yeah.
It's so easy to write concurrent code nowadays, like with both
Let's
routines,
see.
cognitive routines, now this kind of shit.
And actually, this parallel code right now it's good. Just let me check on the WASM code,
Okay, you're gonna do it.
just to see. Yeah, it should have broken, but I think in the past
That's a good thing.
like
That's a good problem. That's a good problem.
in the past it did broke, but I think the guys from the Ryan library, when they see it's like when they see the runtime doesn't support threads, they just execute it as a single thread. That's why the performance is the same, and they do it like that, just not to crash. Because in the past I tried some demos and it just crashed. So yeah. And as you can see, WebAssembly it's really fast, but it's not fast as native. And one of the main things I do in the remarks on the presentation is if you want to use WebAssembly on Node, you don't need. Yeah.
Okay.
If you want to use WebAssembly on Node, if it's just for fun, go for it. But if you want to use it on production or in some side project, don't go, because right now it's not that fast. I think it will never be, because you are running into a native thing, so it's like the same thing. Right now it's really the ecosystem is very, very young, so most of the tooling you have to think around to make it work. And even then, I think for like 2 or 3 years from now, it's where WebAssembly it will be. I think it will be on the same year as the web platform. It will be great. Yeah. Yeah. I can show you a couple more demos. This is like pthreads from C working on the browser. It's really the. I shouldn't have refresh. As you can in the other.
So, like pthreads from the standard C library working
Yeah.
in the browser? Wow,
Yeah.
that's pretty cool.
Let me. I don't know why Windows didn't finish this.
Because Windows.
Yeah. Actually, I'm running the code on Windows, but I'm using Linux subsystem. That's why everything works. At least on the demo. Okay. Sorry. This was a demo that is on this web page, and I will try to. I tried on the weekend. It works really well. You have like p threads from C. They are executing Fibonacci like in two threads, in the main thread and the background thread. Just show the result. I can show you the execution here. So it uses two threads and it just works. One of the things that WebAssembly has right now, to compile it in the AM script and compiler, you need to specify a flag when you are using p threads, and you also need to specify the pull thread size. In the browsers, there is a limit on Firefox for 14 threads, I think. On Chrome, I don't know where is the main value, but I think it's the same because it doesn't make sense to have more than 14 threads on the browser.
Even 14.
Even 14,
So
yeah.
what happens if I try to create 4 threads in the code, even though I call the compiler with the
It only executes 2 because this is
but the code still works.
yeah, the code still works because this is the thread pool size. So you are trying to run like 10 threads, but you have only a pool of 2. So yeah.
So
Only
what
2 execute at a time. Even though from the code it looks like I have all the 10.
You have to do a little bit more managing because you're trying to run.
For most cases, magic number is like what, 16? So 4 codes, 4 cores times hyperthreading. So 16 or 8 even, most cases.
This is another demo. It was the first one. What they tried to do in Rust, because the Ryan library didn't work and the guys really wanted to, but right now it's really hard to add support for threads in WebAssembly for that library. They have done it like a demo on ray tracing. I couldn't make it work on Chrome and WebAssembly. It just goes to the concurrency. It's just 1, and the same thing on, I don't know. It just gives me like a random error in Firefox. I'm using like the next version, best version that already supported. I don't know why, but it's coming there, and it's really great. So
Okay,
that's
that was ray tracing on a browser.
yeah, you can do it with single thread.
Yeah,
You
but
could
it's
just wait like a month for a frame, but yeah.
So you are starting to rendering on on the browser.
So
Okay.
so the future right now, it's really hard to do anything on WebAssembly, even though you could do. I think there is one of the best applications I've seen with WebAssembly besides some of the games that Unity did. And for games right now, it works, but nobody plays them because they play native. One of the best demos I've seen was on Chrome Dev Summit, where I think the guy from Preact and one other guy from Chrome created an application to test image format library converters, where you can convert everything on the browser, and they shipped everything on that application. It's like a PWA where you can just upload to the browser and WebAssembly code just converts the image between JPEG, WebP, and PNG, anything. They could do it with like 400K size. So because they used Preact, they tried to take anything, and for the first frame they had like, for the first page rendering, they just download like 10K even if you have the cache disabled, because in WebAssembly you can load the modules asynchronously, so that even if they are too big. So
I thought you were going to say that you saw some crazy crypto coin mining.
Yeah, I was
No.
going to say that. Distributed crypto coin mining.
because right now the support is a little bit shitty. That's why none of the guys did that. So there was one of the problems in one npm package. The one guy that didn't do the mining. It just stole like the keys. It was really big
I know you are
thing.
a
Yeah.
crypto coin guy, so
No. Yeah.
that's fine.
I was. Right now the value is too low, so you
Not
know.
anymore.
No, the value is too low, so you know.
Yeah.
Just find a viral page and put some
Yeah.
WebAssembly in it to mine it. See how it goes.
But wait for threads, so nobody wouldn't
Yeah.
know because
There you go. Yeah.
so. That's it. Thank you.
All right, nice.
I got a question. So I know that shared array buffer is stuck because of Spectre. Do you know if there's a kind of a date that they will fix
No,
that?
they already fixed it.
Okay.
They are shipping it on a browser. They are still testing it because I think they needed to change something on the code.
Okay. So the performance stays the same.
Yeah, the performance stays. If it didn't, it's like 1%. It's not significant. So
Okay.
because on that time they also had to disable the performance counters of the browser because they were too precise, and with that you could check.
Yeah, you could actually still.
Yeah.
Yeah. Okay.
First.
I have another question. Do you think that in the future maybe the execution speed of the JavaScript engines and the WebAssembly part of the virtual machine will converge because they will also compile JavaScript so more efficiently, bytecode or whatever, or you can even recompile as I mean, it would be possible to write JS to WebAssembly.
Yeah, some guys are trying. Nobody, the creator from JavaScript just becomes angry when anybody says that, because the JavaScript runtimes are really fast right now. You don't need to compile it because the target for WebAssembly is for static language. It's not dynamic. That's why the MVP didn't have like the garbage collector or anything. It will be in the future. You can target them, but it doesn't really make sense, because if you look into a past, JavaScript was a language created in 10 days with a lot of problems, but a lot of virtues. In like more than 25 years have passed, and it's the most used language in the world. It's the language that really runs everywhere. It's not Java, it's JavaScript. So I don't think it will go away in the future, because if you need to like write code in the browser and test it right away, you do it in JavaScript. You can't do that on WebAssembly because there is a compilation step. So no.
Maybe the target is for every use application, like intensive or CPU intensive applications.
Yeah, the target is that.
Also, WebAssembly is not that great to mess around with the DOM, right?
No, because right now it doesn't have a direct API. It will have on the future.
You need to sort of go through JavaScript.
Script to there.
So it kind of
Yeah, but it's kind of like calling the same APIs as JavaScript, or actually going a little
Go directly. It calls the same thing that JavaScript calls, and the way I've said in the earlier, the way that threads work on WebAssembly, it's like web workers. They create a V8 on Chrome, create like a V8 runtime on the side, and just communicate between them. We share the array buffer and all the atomics that were developed into the platform for WebAssembly to support it, and for the workers to be way more performant. So.
No more questions?
All right, nice. Round of applause.
Thanks.